Solving electrical circuits with resistance. So for each of these circuits, you need to come up with a plan and then use that plan to solve for the unknowns in the question. So in question 1, determine the current and voltage for each resistor. Now, what are the resistors? Well, we have one resistor here, and we have one resistor there. So we need to figure out the current and voltage for each one of those. So we're going to need V1, and we're going to need I1. Then we're going to need V2, and we're going to need I2. And then we also need to determine the total current coming from the battery. So we need I total. Now the formula we're going to use is going to be V equals I times R. So now how do we tackle this problem? Well, we need to figure out the voltage in each one first, because we can figure that out. We know that there's 5 volts coming from the battery. That means for every electron that passes through the current, we're going to have 5 volts passing along each branch. So this is going to be 5 volts, and this is going to be 5 volts. Now we can solve for I1. Say I1 is going to equal to V1 divided by R1, just using this equation right here. So we're going to have 5 divided by 35, and that equals to 0.14 amps. And then for I2, it's going to be the same thing. It's going to be V2 divided by R2, which is going to be 5 divided by 25, and that equals to 0.2 amps. Now I total is going to be I1 plus I2, which is going to be 0.14 plus 0.2, which is going to equal to 0.34 amps. Question 2. Determine the current and voltage for the following circuit. So we need to find V1, I1, V2, I2, V3, and I3. So we're going to use the same strategy we used last time. We know the voltage coming from the battery is 5 volts. So we know that V1, V2, and V3 must all be 5 volts. And now we can solve for I's. So I1 is going to equal to V1 divided by R1, which is going to equal to 5 divided by 35, which is what we had on our last question, which was equal to 0.14 amps. I2 is going to be equal to V2, which is 5 divided by 25, which again we had on our last question, which was 0.2 amps. And then I3 is going to equal to 5 divided by 15, which is equal to 0.33 amps. Now to find I total, we're not actually asked for this in this question, but we could figure it out. It's going to be I1, which is 0.14 plus 0.2 plus 0.33, and that equals to 0.67 amps. So we can figure that one out as well. Determine the unknown voltages and currents in the following circuit. So we need to find V1, we need to find I1, we need to find I2, and we need to find V3 and I3. Now for this question, we need to find out another strategy again. We're told that 9 volts of electricity leave the battery, but we don't know the voltage in here or here. So what we need to do is we need to narrow it down so we can find a branch that only has 1 voltage missing, and that's going to be this branch right here. So if you are an electron and you leave the battery, you have 9 volts, you're going to come up here and you're going to subtract some amount of volts here. We'll call this V1. Then you're going to come down here and you're going to subtract 4.5 volts, and you're going to be left with nothing. So we can solve for V1. V1 is going to equal to 9 minus 4.5, which is equal to 4.5 volts. 4.5 volts. Now we can figure out V3. V3 is going to equal to, again, 9, right from the battery, minus the 4.5 it loses there. And that's going to equal to 0, because it's going to come along here. It's going to give it the rest of it over to V3. And then again, we're going to have 4.5 volts. So we got that one. Now we can solve for I3. I3 is going to equal to V3 divided by R3, which is going to equal to 4.5 divided by 14. And 4.5 divided by 14 is equal to 0.32 amps. I2 is going to be similar. It's going to be V2, which is 4.5 divided by 35. And 4.5 divided by 35 is equal to 0.12 amps. So we've solved for all of our unknowns except I1. I1 is going to equal to V1, which is 4.5, divided by R1, which is 10. 4.5 divided by 10 is 0.45 amps. Determine the unknown voltages and currents in the following circuit. So we need to know I1, I2, we need to know V2, we need to know I3, and we need to know V3. So we can figure out I1. Remember, remember we're going to use V equals I times R. So we're going to say that I1 is going to equal to V1 divided by R1. V1 is 5, R1 is 20. 5 divided by 20 is 0.25 amps. So now what we need to do is we need to pick one of the branches to solve for. We know that electrons leaving the battery have 8 volts. They're going to come around here, and they're either going to go this way, or they're going to go that way. So we can pick either branch. So let's pick branch number 2. So for branch number 2, we're going to say that 8 volts minus V1, which is 5 volts, minus V2, which we don't know, and that equals 0, because it's going to give up all its electrons as it comes back to here. So we're going to say V2 is going to equal to 8 minus 5, which is 3 volts. So we got that one, 3 volts. Now we can do the same thing for V3. We're going to say that 8 minus the 5 that it gives up here, because each electron needs to pass by that guy, 8 minus 5 minus V3 equals 0. V3 is equal to 8 minus 5, which is 3 volts. So we got that one. And now we can solve for our I values. I2 is going to equal to V2, which is 3, divided by R2, which is 20. 3 divided by 20 is 0.15 amps. And then I3, same thing, we're going to do V3, which is 3 volts. We're going to divide that by 30, and we're going to get 0.1 amps. So we've solved for all of our unknowns. Find the voltage of the battery. So the voltage of the battery, that's going to be our V total. Our V total is going to equal to V1 plus V2 plus V3. So we got to figure what those are. So that's V1 plus V2 plus V3. So we have V1 right away. So we're going to say V total is going to equal to 5 plus, we don't know the other two. So now we need to figure out what the other two are. So what we can do is we can figure out I1 given the information in number 1 here. And we're using our equation, V equals I times R. I1 is going to equal to V1, which is 5, divided by R1, which is 10. 5 divided by 10 is 0.5. Since this is a series circuit, we know that if I1 is equal to 0.5, I2 is going to equal to 0.5, and I3 is going to equal to 0.5. We can then solve for the other two. V2 is going to equal to I times R, so 0.5 times 20, which is equal to 10 volts. So we got 10. And then V3 is going to equal to I3, which is 0.5 times 5, which is going to equal to 2.5. So now we can add them up. 5 plus 10 is 15, plus 2.5 is 17.5 volts. Find the unknown resistance. So which resistance do we not know? We don't know this one. So we're going to say that R1 is our question. We also don't know V1, and we don't know I1. We don't know I2. We don't know V2, and we don't know I3. So now we need to figure out what we do know and how we're going to solve this. We know that any electron leaving the battery is either going to go that way or it's going to go that way. An electron leaving the battery has 10. We know it's going to lose something at number 1, and then it's going to come down here to branch 3 and lose 2. So we can figure out V1. We know that 10 minus V1 minus 2, because it's going to go like this, is going to equal to 0. So we can say that V1 is going to equal to 10 minus 2, which is 8 volts. So we have 8 volts there. And that doesn't finish our question, but it helps us along the way. We're trying to find the unknown resistance, and we kind of need to figure out everything else before we can do that. So we can now figure out V2. V2 is going to be equal to 10 minus the 8 that it loses in V1, and that's going to equal to 2. So we know V2 is going to equal to 2. So now we can solve for I2. I2 is going to equal to V2, which is 2 divided by 5, and 2 divided by 5 is 0.4. 0.4 amps. So now we're almost done. We can solve for I3. I3 is going to equal to V3, which is 2 divided by 10. 2 divided by 10 is equal to 0.2. Now, why did we do all this? Well, we did all this because we know that if we have an amperage of 0.4 going this way and an amperage of 0.2 going this way, we know when they come together, they must have had an amperage coming through here and then all the way over to here, sort of I1, of 0.4 plus 0.2 or 0.6. Now we can solve for R1, right? R1 is the last one we need to do. Since V equals I times R, R1 is going to equal to V1 divided by I1. V1 is going to be 8. We figured that out. I1 is 0.6. And when you do 8 divided by 0.6, you get 13.3 ohms. And that's the answer to our question. Find the unknown resistance. So which resistance do we not know? We don't know this one. We don't know R2. That's our question. We also don't know I2 or V2. We don't know I3, and we don't know V3. And lastly, we don't know I1. So now what can we figure out first? We can figure out I1. I1 is going to equal to V1, which is 8 divided by 25. 8 divided by 25 is 0.32 amps. That's pretty good. That's the amount of amperage that's leaving the battery every time. So we know that we're going to have 0.32 amps to split between our two branches. Now what else can we solve? Well, we know that if we leave with 20 volts, our electrons are going to give up 8, and then they're going to give the rest to the other two branches. So for V2, we know that 20 minus 8 minus V2 is equal to 0. V2 is equal to 20 minus 8, which is 12 volts. And then we can do the same thing for V3. We know it's going to leave with 20, so 20 minus 8 minus V3 equals 0. V3 is equal to 20 minus 8, which is equal to 12 volts. Now we can solve for I3. I3 is equal to V3, which is 12, divided by R3, which is 50. 12 divided by 50 is equal to 0.24 amps. Now we can solve for I2. I2 is our question. We know that I1 is equal to 0.32. We know that 0.24 went to the branch 3. The rest of it must have gone to I2. So I2 must equal to I1, which is 0.32, minus I3, which is 0.24. So 0.32 minus 0.24 is equal to 0.08 amps. 0.08 amps. So now we're almost done. We need to figure out R2. Well, what's R2? Well, again, using V equals I times R, we can figure out that R2 is going to equal to V2, which we figured was 12, divided by I2, which we just found out was 0.08, and 12 divided by 0.08 is equal to 150 ohms. And that's the answer to our question. Solve the following circuit diagram by finding the unknowns. So all the unknowns we need are on the right-hand side. Pretty much need to figure out everything. We need to figure out I3. We need to figure out V3. We need to figure out I2, V2. We need to figure out V1. And then we need to find out VT and RT. So there's lots of things we can do. The first thing we got to start with is the one that we can figure out. We have two of the unknowns in the bottom here. Again, we're going to use V equals I times R. So we're going to say that V1 is going to equal to I1, which is 1, times 3. So we get 3 volts. So V1 is 3 volts. Now, what's the next thing we can figure out? Well, we know that if we have a current going through this guy down here of 1, then we must have a current going through this guy of 1 and a current going through this guy of 1 because it's a series circuit. So we know I2 and I3 are both 1 amp. We also need to find I total. Okay, now we can figure out V3 because we have two of the unknowns. V3 is going to equal to I3 times R3, so 1 times 5, which is 5. So V3 is 5 volts. And then lastly, we can figure out V2. V2 is going to be equal to R2 times I2, so 1 times 4, which is equal to 4 volts. So V2 is equal to 4 volts. Now we can almost finish. Easiest one probably is the VT. VT is going to equal to V1 plus V2 plus V3. So V1 is 3, V2 is 4, and V3 is 5. So that's 13 volts. IT, we know IT is going to be the same as the current going through everywhere else, which was 1. So that's going to be 1 amp as well. And now probably the harder one is going to be the RT. And since the series circuit's really not that hard, it's just going to be R1 plus R2 plus R3. R1 is 3 ohms, R2 is 4 ohms, and R3 is 5 ohms. So we're going to get 12 ohms. And we're done. Solve the following circuit diagram by finding the unknowns. So similar to the last question. So we need to find I1, we need to find I2, we need to find V2, we need to find I3, V3, we need to find V total, I total, and R total. Now I said it's similar. The only difference is now it's a parallel circuit, so it's going to make it more complicated. So what can we figure out right away? Well, we can figure out I1 right away. Again, we're going to use V equals I times R. So I1 is going to equal to V1, which is 9, divided by R1, which is 3. 9 divided by 3 is 3. So 3 amps. So I1 is 3 amps. Now what else can we figure out? Well, since it's a parallel circuit, we know the voltage 1 is 9 volts, therefore voltage 2 must be 9 volts, and voltage 3 must be 9 volts, because it's going to be shared the same through the 3 branches. So voltage 3 is 9 volts, and voltage 2 is 9 volts. Now we can solve for I3. I3 is equal to V3, which is 9, divided by R3, which is 9, so we get 1 amp. So I3 is 1 amp. Same thing for I2. I2 is equal to V2, which is 9, divided by 6. 9 divided by 6 is 1.5 amps. So I2 is 1.5 amps. And now we can figure out our totals. VT is going to be pretty easy. We know VT is going to equal to 9 volts. Each branch has 9 volts given to it, so we know that the total voltage coming from the battery must have been 9 volts as well. IT, in this case, is going to be the sum of all these guys here. So IT is going to equal to I1 plus I2 plus I3. I1 is 3, I2 we figured was 1.5, and I3 we determined to be 1. So 3 plus 1.5 plus 1 is equal to 5.5 amps. So 5.5 amps. And then the last one, RT, that one's going to be more complicated because it's a parallel circuit. And remember, we need to do 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. 1 over RT is going to equal to 1 over R1 was 3, R2 is 6, and R3 is 9. I'm just going to bring this over to this side to make a bit more room. So we're going to have 1 over RT is going to equal to 1 divided by 3 plus 1 divided by 6 plus 1 divided by 9. And that equals to 0.611. Now to figure out RT, it's going to be 1 divided by 0.611. And that equals to 1.64 ohms. 1.64 ohms. And we're done.